We are starting the demo video for DC servo motor speed torque characteristics. In this trainer kit you have two units. One is the motor unit, other is our main unit. Let's first talk about the motor unit. In the motor unit you have a DC servo motor for which the armature and field lines are coming on this terminal with the sensor output and voltage terminals. That is why there are number of pins. This is an inductive sensor. This sensor is used to measure the RPM of the motor, and the field and armature windings are also coming on these terminals. This is a polarized terminal, so you have to make sure that this is not a universal type connector. You have to match it with the socket provided here. Once you have made the connections, lose the S1 and S2 so that there is no tension on the motor. Then before starting, make sure that the armature and field excitation is at minimum, that is towards 0. Then turn on the trainer kit. On the trainer kit, this is our field voltage and current, this is our armature voltage and current, and this is the RPM meter. So first we will set our armature to maximum and then increase our field excitation to the maximum point. Then we will set our RPM to 2500. We will first let it settle down. So this is the first experiment which we are going to do. In this manual you will see multiple experiments. First is for torque measurement. For torque measurement the formula is S1 minus S2. This one is my S1, this one is my S2. Each deviation is 20 grams. So the calculation will be S1 minus S2 into R square. R is the radius of the pulley. The radius is 2 centimeter. So weight is in kg. So this will be our calculation. T torque is equal to S1 minus S2 into R square, where R is our radius, that is 2 centimeters. So now we will note down the readings of S1 and S2 with respect to the armature current. So for 0, 0 it is 0.36, but we will only start measuring once we have set a fixed weight. So now we have to consider this as 0 position, as there is no change in the current. As soon as we get a change in the armature current, we will start measuring it from that particular point. So now we can consider this as 0, and now for every division, that is for 20 grams, we will start counting the S1 and S2 value and the current of the armature. So for 20 gram, this is actually counting as 5, 6, 7. 7 at this point. This is 7 unit, 5, 6, 7, 8. This is 8 unit. S2 is 5 units. And this is 0.37. That is our initial reading. This is our consider as our 0th reading. We will consider that as a base level. And now we will start calculating This one is at S1 is at 10 and S2 is at 6. This is our reading number 1. So you need a base reading, so that this one is basically the difference is 2 and the difference is 1. So for this first reading will be considered as S1 is 2, S2 is 1 and R square, that is the radius, that is 2 centimeter. If I connect it to 2002, that is 2. 1, 2, 3, yes, this is 2. This is meter, this is in kg. And now this is only units. For every unit is 20 gram. So this will be 2 into 20, 40 grams, that is 0.04. And this is 20. This is 20 grams, 0.02 into 0.002 square. So this will be the value of our torque for this particular weight. Now we will go it further. This one is 13 units and this one is 5, 7. So difference is basically 2 and this one is 5 and the current is 0.43. So now the reading for this will be 5 into 0.2 into 20. So the reading will be 5 into 20 into 100. So it will be 100 into 1200. So we will take readings This one is 17 points. We are counting each unit. So this is actually 17 unit. That will be 17 minus 8. So that will be 8, 7, 8, 9 units. And here it is 9. So 9 minus 5, that is 4 units. And the current is 0.49. This is 20 and 11. 20 and 11, which comes to 10, 12 units and 6 units. Multiplier of 0.53. Now we'll turn off this setup by turning both to the minimum position and turn it off. Now we'll move on to the table. Let's come to the table. So what we have the readings is, this is our 0th reading, that is for reference, and each count which we have calculated is equal to 20 grams. So now we will remove this page and make our new table as is S1, S2 and current. For current we had 0.4, 0.43, 0.49 and 0.53. For S, we are measuring every unit of what we have calculated here is equal to 20 grams. So for that, the difference from 8 to 10 was 2. So 2 into 20 is 40. So 40 grams. And this one is 1. 5 to 6, difference is 1. So this is 20 grams. We are talking in grams and ampere here right now. This is grams, this is current is in amperes, and the radius, for torque, the radius R is 2 centimeter. So we'll go for the next calculation. This is 13, which is actually 5 units. The 5 I do 10. And this is 2 unit, 2 to the 4, 40. This one is 9 units, 180. This one is 4, 80 grams. This one is 12 grams, 12 to the 24, 240. And this one is 6, 120. So these units are in grams. So we'll convert it to kilogram. 0.04, 0.1, 0.0, 0.02, 0.04, 0.0. So now these units are in kilograms. So now if I want to convert that into centimeter to meter, that will be 0.002 meter. So the calculation for torque T will come as T is equal to S1. So for calculating torque, we'll go S1 is our 0.04 in minus 0.02 into 0.002 square. So now we'll first calculate all the torques and then input the value.